let us discuss few questions on the distance formula. We have discussed how a distance formula works, we have discussed where a distance formula should be used, and now we are going to discuss a few examples on distance formula. In these examples, I'll discuss when to use the distance formula, in how many cases the distance formula can be used, and I'll include some examples from the textbook that we have, that is book 2, exercise 6b. I'll be doing few questions that will be a part of our curriculum, and I'll be discussing few questions that will clarify most of the concepts regarding distance formula. I'll start with the basic level question number 1. This is again one more time exercise 6b book 2. Okay, question number 1 says find the length of the line segment joining each of the following pairs of points. And in the first part there are 2 points given. The first point is named A, and the coordinates of A are 2, 3. It will be read as A 2, 3. And the second point that is given is B, and the coordinates of B are 9, 7. So we have to find the length of a line segment which is actually formed by these 2 points. First thing that you will have to remember, the distance formula which I had told you in the previous video, AB, modulus of AB shows the length of a line segment. AB is equals to square root of x2 minus x1 square plus y2 minus y1 square. I hope this is clear. Yeah, I hope it was clear. Anyways, so then this is x2 minus x1 square plus y2 minus y1 square inside the square root. This is the distance formula which I have already discussed in the previous video. What are the uses of distance formula? Distance formula can be used to find the length of a line segment, This is the first use, and the second use is distance between 2 points. These are the 2 major uses of distance formula of rectangular coordinate system. There are a few more cases that I will be discussing later. Okay? So distance formula looks like this. This is used to find the length of a line segment. This can also be used to find the distance between 2 coordinates, 2 points on a rectangular coordinate system. This is one way of mentioning the distance formula. The other way could be, instead of modulus of AB, I can use modulus of D is equals to the same thing. One more way this formula can also be written as modulus of D is equals to square root difference of, oh my god, I'll run out of space. I'll write this formula here. Note it down because I'm going to erase it. Modulus of D is equals to difference of abscissas. I hope you remember what abscissas means. Difference of abscissas square plus difference of ordinates squares. So this is one more way of mentioning the distance formula. I hope this is readable. Difference of abscissas squares plus difference of ordinates square. This is one more way of mentioning the distance formula. Abscissas mean the x components, ordinates mean the y component. Okay? Since we know we have to find out the length of a line segment or the distance between 2 points, so we have 2 abscissas means 2 x components. We'll have 2 ordinates means 2 y components. We take out the difference of the x components and then square it, plus we take out the difference of the y components and then square it, and then we can just use this formula. So this is one more way of writing the distance formula. Just wanted to share it in case in future you might need it. Anyways, I am erasing it. I hope you people have written it down. In case you haven't, you can always forward, rewind the video and then watch the formula again. Anyways, coming back to question number 1, find the length of the line segment joined by these 2 points A and B. I am just randomly going to plot a line here. This is a line segment and these are the 2 endpoints. Let's say this is A, let's say this is B. The coordinates of A are 2, 3 and the coordinates of B are 9, 7. These are the 2 endpoints of a line segment and I want you to find the length of the line segment using the distance formula. Okay? First thing, I'll just name these points. A has already been given. I'll say let AX1, Y1 is equals to 2, 3 and BX2, Y2 is equals to 9, 7 be the 2 endpoints of the line segments, and AB is equals to x2 minus x1 square plus y2 minus y1 square and the square root. So I just substitute in all the values. I'll find the length of the segment AB. X2, what is the value of x2? X2 is 9. So in place of x2 I have placed 9 minus, in place of x1 I am going to place 2, x2 minus x1 whole square plus y2 minus y1. Y2 is 7. So in place of y2 I am writing 7 minus y1 is 3. I am writing 3 whole square and then square root again. 9 minus 2 is 7 square plus 7 minus 3 is 4 square. 7 square becomes 49 plus 4 square becomes 16 square root. 49 plus 16 becomes square root of 65. This is not a perfect square, so I'll just leave it like this and I'll mention unit. This is the length, square root of 65 units. So the length of AB is square root 65 unit. I hope this very basic use of the distance formula is clear. If you look at the distance formula again, distance formula, from the distance formula we can find out the length of a line segment if I have the coordinates of both the end points. x1, y1 should be there, x2, y2 should be there. Only then you can find out the length of a segment or the distance between both the points. This formula may also be used to find out one of the components of a point. For instance, I can give you the distance between the 2 points. I can give you the first point x1, y1 completely, and then I can give you x2, y2. I will just give you x2. I will not tell you what y2 is. The y2, the second y component, is the unknown, and then I'll ask you to find out the value of that second y component, which can also be done using the same formula. Distance is there, x1, x2 are there, y1 is there. The only component is going to be, only unknown is going to be y2, which can be found out by forming an equation in terms of that unknown variable. The same thing could be x1 is given but x2 is not given, y1 is given, y2 is given, distance is given. You can find out the value of the missing unknown. Collectively, the thing is this, there has to be only one unknown. That one unknown can be the distance, that one unknown can be the x component of a point, that one unknown can be the y component of a point. The rest of the things should be known. If there are more than one unknown in this equation, then the thing will not work out. I hope the basic use of the distance formula is clear. Now we will just move forward in the next videos and we will be discussing more questions on distance formula, more cases of distance formula. I hope the basic use of the distance formula is clear and very much understood. Thank you so much. In the next video, I'll continue discussing few more cases of the distance formula.